Alright, here we're going to have a stoichiometry problem. It's going to be a mass mole problem, as you can see that I've got titled at the top of it. The reason it's a mass mole problem, when you make your chart out that I'd ask you to make out, you're going to see that your unknown is a mass. They want to know the mass, how many grams of copper, and your known is moles. So it's a mass mole problem. It'd be the same way if your unknown was moles and your known was mass. The fact is it's got mass and moles. It's a mass mole problem, or you could call it a mole mass problem. It doesn't matter. What matters is you're going to have to go to the periodic table one time. You're going to have to seek out the molar mass of one chemical, and that chemical is the one they want to know how many grams of copper. So we have to go find out copper's molar mass. If they said we have 2.10 grams of aluminum, or gave us the exact amount of grams, we'd have to go find aluminum's molar mass. So let's bring up a periodic table real quickly here, and we can see on this, you can't see it very well, but it's 63.55 grams per mole. So we can put our periodic table away, and let's just write that down: 63.55 grams per mole for copper. So for copper, it's 63.55 grams per mole. Just something we need. Let's make our chart. Our chart has, remember, our known, or our given, and it has our unknown. So our known, it's right here, 2.1 moles of aluminum. So 2.1 mole of aluminum. And our unknown, how much what? Copper. As much, what do they mean by much? What are the units? Grams. How many grams? So grams of copper. Okay. I also wanted you, just for practice, to put the reactants and the products. Let's see. So if you look at the reactants, it's aluminum. Products. So we have aluminum for one of the reactants. What's the other one? What's it reacting with? Copper chloride, copper 2 chloride. And the products, copper and aluminum chloride. And what type of problem is this? You look at what they give you mass. Excuse me, they want to know mass. So it's a mass problem. Right there, that tells you go to the periodic table. We already did. And it's a mole problem. The reason it's a mass mole problem is because my known is moles, my unknown is mass. I've got mass and moles. If it was a mass problem, we'd have to go to the periodic table for both the mass that's given and the mass that's asked for on the molar masses. Okay, once we're done with our table, we write our fraction from our balanced coefficients. So what's our fraction going to be? Remember, the unknown always goes on top. What's the unknown? How many grams of copper? So we go in front of copper, and oh, this isn't balanced yet. We've got to balance it. So we have 2 chlorines and 3 chlorines. If I put a 2 here, that gives me 6 chlorines, and if I put a 3 here, that gives me 6 chlorines. Now this 3 also gives me 3 coppers, and this 2 also gives me 2 aluminums. There we go. So now we can go ahead and write our fraction out. The known, and these are always going to be in moles. What was my known? Aluminum. So there's a 2 in front of the aluminum, not to be confused with this 2.1, which is our given. 2 moles of aluminum. And what's my unknown? Unknown always goes on top. Copper. 3 moles of copper. So now that you've got that, every stoichiometry problem needs that fraction. It doesn't matter if it's a mole, mole, mass, mass, volume, volume. They all need that fraction. So we've got our fraction, which goes on the bottom. Which number? The given or the unknown? The known or the unknown? The known always goes on the bottom. So we're ready to start our dimensional analysis expression. And to do that, you always start with the given. Always. That's one thing that stoichiometry has in common. Every question, you start with the given. So you go back to your chart. Where did you get your given? Your known? Right here. Right from the problem. You need the units. And you need the chemical. Aluminum. Then you take it times fraction. What needs to go on the bottom? Moles of aluminum. Remember, so it can cancel with the one here. It's 2. We already had our fraction set up so that the aluminum's on the bottom. And then for every 2 moles of aluminum in the balanced equation, you're going to use 3 moles of copper. Now times that by the periodic table's molar mass. We already said 1 mole is 63.55. Where's mole going to go? On the bottom. That 1 mole always goes with one of your numbers in your fraction when you're getting the molar mass from the periodic table, because that's what it is. 1 mole of any substance weighs that many grams. For copper, it's specifically 63.55 grams. Now, mole cancels with mole, and that can only cancel with copper. Mole of aluminum only cancels with mole of aluminum. Those all cancel to 1. Now we just do the arithmetic. If you don't like that there's not a number here, just put it over the number 1. So let's take the entire top, the numerators, multiply them together, and then the entire bottom we can see is going to be 1. 1 times 2 times 1. So the bottom will be something over 2. Did I say 1? Bottom's going to be something over 2. The top, let's get our calculator out. So what are we going to do? We're going to take 2.1, you don't need to write the 0, but you can, times 3, times 63.55. Now we can keep all those numbers for right now. We'll get rid of some of them later. So it's 400.365. And that'll be grams of copper. Oh, grams of copper up here. So now I'll just divide that by 2. So let's hit divided by 2. And we have 200.1825. $200.1825 grams, and that was copper. Let's go back to our given. How many sig figs in our given? 3. So we can keep 3 sig figs. So we know with certainty that this is 200 grams of copper. That's the answer. Alright, so that's a mass mole problem. Study this again and go do your homework and study hard. Pass all your tests.